Today we are going to see about the data structures. The data structure is used to define the group of element. The element can be organized in a particular way. The data structure is provide the efficient way for organizing our data. Why we need a data structures? The data structure is particularly a way of storing and organizing the information in a computer. It is used to store our data in a structured way in the computer memory. Each data such that allows the data to be stored in the specific manner. The data structure allows the efficient data search and retrieval. If you want to search any content in your memory, the data structures is to be provided the efficient way for searching our content. Because the data is to be arranged in a specific manner. The specific data structures are derived to work for specific problems. It allows to manage the large amount of data such as the large database and indexing services such as hash table. The data structure can be classified into the linear data structure and the non-linear data structures. The linear data structure is classified into static and dynamic. The non-linear data structure is classified into tree and graph. And again, the static data structure is an array data structure. The dynamic data structure is provided with three types. The first one is the linked list, second one is the stack, and next one is the queue. The non-linear is providing categorized into the two types, tree and the graphs. Static data structures. The static data structure example is the array, because if we choosing the array data structure, the size of the array is to be a fixed one. We couldn't change the size of the array in the runtime. That's why the array data structure is called as the static data structure. In a static data structure, the size of the structure is fixed one. For example, in the diagram, the element may be the fixed size. The array size is to be indexed in the 0 to 8. So the array size is to be the 9. The value is to be indexed into 0 to 8. So the element is to be organized in the 0th position to the 8th position. In a static data structure, or otherwise the array data structure, the element is to be stored in the sequential manner. But in the dynamic data structure, the data is to be not in the continuous memory location. They may be arranged in the different locations. We need to use the pointer variable to fetch the next elements. In a dynamic data structure, the size of the data structure is not a fixed and can be modified during the operations performed on it. In a dynamic data structure, it provides the user can modify the size of the element. If you need to change the size of the element, you can, depends upon your input, the size of the structure may be modified. Array in data structure. An array is a collection of values of same data type stored at the contiguous memory locations. That means the array element in previous we will discussed, the array element must be stored in the sequential order. It must be stored in the continuous memory locations. For example, if my array size is the 5, the index value is started from 0 to 4. The element may be the 5, 10, 15, 20 means it will be arranged in 0, 1, 2, 3, 4, 5 order. It is used to store the multiple values of the same data type together. So array, the elements in the arrays must be in the same data type. It is easier to calculate the position of each element, and simply adding and subtracting to a base value is possible. If we will give the a of 2 means we can easily fetch the index value of array 2 element, we can get it. The syntax of the array is data type, array name, array size. So the array size is the fixed one. If once you fixed the array size, you couldn't change that array size in your runtime. So if you give the element for that array, the element must be within the size of your array. The next one is the linked list. The linked list is dynamic memory allocation. A linked list is a linear data structure in which the elements are not stored in a contiguous memory location. When compared to array, the linked list not stored in continuous memory locations in the memory. The linked list must having the node. The node can be classified into the data and the next pointer. The linked list is to be classified into singly linked list, doubly linked list, circularly linked list. In a singly linked list, the node must have the data and the next pointer. The data is nothing but what the element is to be stored on that node. That element or the information is to be called as the data. The next is nothing but it is the pointer. It points to the next list for this current node. So the first node is to be always called as the head node and the end of the node is called as the tail node. In the end of the node, it will be stored the null pointer because in a singly linked list, the last node must be the null value. It doesn't point to the next value. Each node has the data and a pointer is assigned to the next node. The diagram shown the model singly linked list. So in this node, it separated, the node is to be partitioned into two. The first one is the data, next one is the next. The next is to be points to the next node address. And the second node contains also the data and the next. This next pointer is to be point to that next list of this node. The last, if the third node may be the last node means it must be the null value. It doesn't point out to the next node. And the singly linked list, each node point to the next pointers only. In a doubly linked list, the doubly linked list contains the extra pointer, typically called the previous pointer. In a singly linked list, we can follow up to the next list only. But in the doubly linked list, it contains the three partitions. First partition is the previous address. The next one, the second one is the data or information. The third partition is the next pointer. So doubly linked list is connected in a two-way. The node must be connected into the previous node and as well as the next node. A doubly linked list contains the extra pointer, typically called as the previous pointer, together with the next pointer and the data which are there in a singly linked list. So in the below the doubly linked list diagram, A node, B node, C node, D node. The A node having the previous node and the next previous pointer and the next pointer. If the A is the head pointer means A previous is null, the A next pointer is shown to the memory address of the B node. The B is contains the previous and as well as the next. B node previous is contains the address of the A node. B node next pointer is contains the address of the C node. And as well as the C node is contains the previous and as well as the next. The C previous is contains the address of the B node. The C next is contains the address of the D node. The D node is contains the address previous contains the address of the C. The next is to be the null because it may be the last one for the doubly linked list. So the last node must contain the null pointer. The circularly linked list doesn't have the end node because the end node must be connected with the head node. A circularly linked list is a variation of a linked list in which the last element is linked to the first element, the form of a circular link. For example, then the circular linked list, three nodes are available. In this, it will be linked in the concept of the singly linked list. So it contains the data and as well as the next pointer. The next pointer points to the second node and the second node next pointer points to the third node. The last node, the third node may be the last node means it points to the next pointer is the head node of that list. So it doesn't have any end